Okay, let's look at question number 8, which is solving the systems by elimination. So remember that when we solve by elimination, what we want to do is have x's and y on one side of the equal sign and our constants on the other side. So for this first system, we are going to add 1 on both sides, give us negative 2x plus 6y is equal to 1. And for the other system, we're going to subtract 2.5 from both sides. And when we do that, we are going to get 5x minus 15y is equal to negative 0.5. So remember, it doesn't matter if we're going to say I'm going to eliminate the x's or I'm going to eliminate the y's. I'm going to just, for simplicity's sake, I'm going to eliminate the x's. So I'm going to multiply the first system by 5, and I'm going to multiply the second system by 2. Okay? When I do that, what I will get, so when I distribute that 5 into that first system, I would get negative 10x. 5 times 6 is plus 30y. And 5 times 1 there is 5. In the second system, when I distribute in that 2, I will get 10x. And then 2 times negative 15 is negative 30. And 2 times negative 2.5 is negative 5. So draw your bar and then say, okay, how are we going to eliminate these x's? When you have negative 10x and 10x, if we add them, my x's eliminate, right? Because by choosing the 5 and the 2, I was choosing to eliminate my x's. Now, something interesting happens with this example. So the x's are gone, negative 10x plus 10x eliminates, right? But then when we go to our y's, we're going to have 30y plus negative 30y. That eliminates as well, right? That technically gives us 0y, or that just gives us 0, sorry. 30 minus 30 gives us 0. And then if I go over onto this side, I have 5 plus negative 5. This also gives me 0. So we've never done in class or in any of the videos an example where we get 0 is equal to 0. If you get this, and it's not actually going to happen on the test, but I'll just show you what it means. If you get this, it means that there's actually going to be an infinite number of solutions. So infinite solutions, if ever you get 0 is equal to 0. Now, in order to prove that there's infinite solutions, I'm going to rewrite each of these in the form of y is equal to mx plus b. And remember that infinite solutions means that these two are identical equations. So let's rewrite each of these in the form of y is equal to mx plus b. So for my first one, I'm going to add 1 to, I'm going to isolate the 6y. And it's positive, so I'm going to get rid of that negative 2x, and I'm going to get rid of that negative 1. So I get 6y is equal to positive 2x. I bring x to the right-hand side, plus 1. Then let's try this plus 6, this plus 6, and this plus 6. So we have y is equal to 2 over 6 reduces to 1/3. So my slope is 1 over 3x plus 1 over 6. So my y-intercept is going to be at just under 1, right? 1/6. Okay, let's rewrite this guy in the form of y is equal to mx plus b. So in this case, I want my y to be positive. So I'm actually going to bring that negative 15y over here. And if I do that, I would get 5x plus 2.5 is equal to 15y. I want to isolate my y, so get rid of that 15. Okay, 15 over 15 cancel, and I have y is equal to 5 divided by 15 reduces to 1 over 3x plus Now this I recommend typing in your calculator. So 2.5 divided by 15. So I should have my calculator here. 2.5 divided by 15. And then if I go to Math 1 fraction, that reduces to 1/6. And if you compare these two, so this blue graph, y is equal to a third x plus 1 over 6. This graph, y is equal to a third x plus 1 over 6. These are identical graphs. They would, if you graph this, actually we could graph it. 1/3 x plus 6. So let's just quickly look at this. In a bracket, 1 over 3x plus 1 over 6. These are going to be identical graphs, right? They have got the identical slope and y-intercept. So that means they would have infinite solutions. And then I just hit graph. There's your y1 and there's your y2. So they would have infinite solutions.